going to go ahead and get started then, because everybody should know this is happening and we're not going to chase them down. So we have, it looks like online, the majority of the people here were at least here last quarter. But I'm going to go through this. I'm going to go through this like we had the full class attendance we were expecting. So this is a little joke that you might remember from last quarter. First of all, welcome. You should all probably know I'm John Davis. I'll be your host for this quarter as we virtually collaborate on everything. So you remember this joke from last quarter. If you get good enough at automation engineering, you can show up to work looking like this dude and still get paid a lot of money. So life goals. I'm not an expert on anything. I do have previous experience in automation engineering and systems integration, but I'm not necessarily a qualified expert, and I'm not a professor. All of the information we go over is going to be my personal opinion and does not reflect the views of UC Davis. Check up on me, Google all the things I say and make sure they're actually true. And please catch me on mistakes because it helps me learn too. How's the volume? Everybody can hear me okay?
It's good.
Good. All right. So the last two quarters, the first quarter, we went over 3D modeling in SolidWorks, 3D printing, drawing in 2D in AutoCAD. We did a design for a control enclosure that we then built with the hardware donated by Automation Direct. And then towards the end of last quarter, we did the assembly and did some live testing on that panel. So my goal for this quarter before our status quo changed was actually to pretty much just do PLC programming and testing. But because we're going to this virtual platform, it's going to be a little bit more difficult to do that and a little bit less valuable for you because it's going to be remote and it's not hands-on in person. So we are still going to do some of that. I'm going to have you guys email me code and we'll test it live together in a collaborative environment. I do have the panel right there on my wall. So the other thing we were talking about a minute ago is I'm working on getting a webcam that I'll set up here behind me so you can see what's going on with the panel live as we're executing. But I don't have that here set up yet. So that'll be hopefully next week. Moving forward, we'll have that available. So this quarter, what I want to do is go back over some of the things we already covered because we have a lot of new people joining us and there seemed to be a lot of interest in the SolidWorks and AutoCAD even more than the programming side. So I'll share here the results of the survey. So this is a homework assignment on Canvas. So 17 of you guys got to that. That means there's like 5 people who haven't done this yet. So if you're here and you haven't done this yet, please go complete the survey. But it looks like about half of you are planning to put in as much time as our meetings will take for this quarter, which is fine because we're going to do some collaborative work. I do encourage you to play around with the things we're going to cover on your own time and really, you know, at least try to apply what you learn, what we go over on your own, explore any things you were unsure about, send me emails. This is going to be a lot more valuable if you put in a little bit of time on your own rather than just coming to these meetings. Like I said, there was a lot of interest in AutoCAD, so we'll definitely spend some time on that. Almost as much interest in SolidWorks, so that'll be good. Unfortunately, we don't really have access to 3D printers this quarter, unless they change something that I'm not aware of. I don't think that's going to be available until the quarantine is lifted. But we can still go over how to set up 3D prints so that whenever you do get back on campus, you can go print up all the stuff in your library that we create this quarter. This was a little surprising to me, but it looks like there's actually not nearly as much interest as I would have hoped for PLC programming, which is also fine. I think this is probably the most valuable thing we cover in this seminar in terms of breadth of knowledge and applicability to having a career in chemical engineering, especially if you go into like process engineering, any kind of manufacturing. Ladder logic based control is really important, as well as instrumentation, but you know, not everybody's going to work on that. So
I do it. Ladder logic.
Okay, so we have 3 people chiming in that say they want to program. So don't worry, we're going to cover all the bases, and I'll get into the details of that in a little bit more. But yeah, we'll definitely do some programming, and we'll make it work. I don't think I'm going to be able to set it up to where you guys are going to be able to directly log into the PLC remotely. But what we'll do is, like I said, you email me your code and I'll upload it and we'll test it live with video, which is almost as good. So other topics, other ladder logic programs. So this is something that I wish I could do more. I really wish I could demo some Allen Bradley platforms, but unfortunately, their hardware is a lot more expensive and they don't give it out for free. So while I understand that this is something that somebody wants, and for good reason, it's not as detrimental as you think. Honestly, switching between ladder logic platforms is easier than switching between like C++ and Python and MATLAB. Like it's actually closer between different ladder logic platforms than it is with scripted programming languages. So you're not missing out a ton by starting out in our Click program. And I will say it's the program we're using for ladder logic is 100% like the easiest, most user-friendly program I've ever seen. So I think you're actually in an advantage starting with the Click software. And unfortunately, I don't have access to any other ladder logic software. So we're going to work with what we got. So project engineering design using AutoCAD. I'm going to ask whoever submitted this to send me an email with a little bit more detail of what you were actually looking for. That could mean a few different things, and I'm just not sure what you're asking. So shoot me an email. So we're going to record these lectures. They'll be available. I probably won't do any solo like where I just like talk to the camera and upload that as a video because I'm planning on putting like 4 hours a week into this class already. But everything will be recorded. I just started a YouTube channel, so I'm going to try to upload all the videos there. Bear with me as I figure out the technology. Yeah, and then I had one more question about, is this going to be purely instructional or are we going to do a project as a group? So we're going to do, I'm going to try to make these sessions as hands-on as possible. And we're definitely going to be doing individual projects. If you guys are interested in working on group projects, we can talk about that. One of the things we need to do is actually finish up and clean up the drawings for this PLC panel we have here. Those aren't quite finished. So if you're interested in working on that, that's definitely an option for group projects. So dovetailing off of that, we also sent out a when to meet, and it looks like 14 people have answered this, assuming I know how this technology works. So interestingly, a lot of people said they weren't actually available during the Monday 6 to 8 session that this class is scheduled for. So it looks like the most availability is Monday 2 to 3. And then the next is going to be like Wednesday 2 to 3. So we'll probably do 2 one-hour sessions in those time blocks. And then if you guys are, if there's a lot of people still online that want to keep working, we can probably extend past that time slot a little bit because I don't really have anything that's demanding my time right after either one of those. So if you haven't filled out the when to meet yet, please go do that. And once that's expired tomorrow night, I'll send out an updated email and update the syllabus about what our actual meeting time is. So if you guys have any feedback about doing a 2-hour block versus 2 1-hour blocks, let me know. But I think probably we'll go to 2 1-hour blocks just because it'll probably allow the most people to attend and nobody will get burned out on that 2 hours. So the next thing is interesting. So I just want to go over the syllabus real quick. These hours will be updated. I'm probably going to do a minimal amount of assignments this quarter. They're going to be small stuff, but again, we'll probably just have like 3, maybe 4 items that you're required to complete. And those are going to be really what's detailed below. So we'll do an electrical schematic in AutoCAD, model something in SolidWorks, develop a program, and then work with me in a live session to actually test that program. For those of you that were participating in the previous quarters and already did these first 2, you're more than welcome to either just submit a note that says I already did this, or resubmit, or do something new and challenging. So as far as scheduling, we're here in week 1. I think I'm going to start off going over AutoCAD in the first 2 weeks, and then go to PLC ladder logic, and then go to SolidWorks. Now, that being said, it sounds like there's a lot of interest in programming, so I might do like AutoCAD in the first session, and then programming in the second session of 1 week, and split things up like that, or hold an additional session if you guys want to. Again, if you shoot me an email, let me know what you think of that. Otherwise, I'm just going to keep making decisions in vacuum if I don't get feedback. Yeah, that's it for syllabus. Moving on. If you don't have access to the Google Drive for this class, shoot me an email so I can add you, because I know there's a lot of people already in there, and I'd like to add people that are actually going to participate and not just give a big file dump to everybody who signed up. So again, if you don't have access to the Google Drive and you want that, shoot me an email. This is where we're sharing all the files for like the panel drawings. And I've put a bunch of reference files on there that you probably will never look at, but may be super helpful to you depending on what kind of career you go into. Also, if you're not a senior, it will help you out in 158B. So again, if you're interested in that, shoot me an email, ask me specifically what I'm talking about, and I will get back to you. So the software we're going to use SolidWorks for 3D modeling. There's also a browser-based program called Onshape. This is all covered in the announcement I sent out as well. AutoCAD's really not good for 3D component modeling. It is used for some BIM modeling and stuff that is really complicated that I don't do very well. But I have seen it used to like model a distillation tower and all the associated instrumentation that goes along with that. We won't be doing that, but just be aware that that's out there. So AutoCAD we will be using for 2D. That's going to be electrical schematics and P&IDs. And at least in my experience, pretty much everybody uses AutoCAD for like basic level stuff. And then most other softwares that are used for more complicated, specific kind of niche operations. So that's why we're using AutoCAD. And you should have all seen the announcement on Canvas. This goes over how to get access to the software. So I just want to go over this real quick to make sure everybody's on the same page. If you have a Windows machine, you can download and install all the software we're going to use this quarter. It's all available for free. I've posted links here to get it. We had a question before we started about SolidWorks. It's a little bit complicated. If you follow this link, there's a download for a text file that has instructions for how to download and install it. If you get stuck on that and you're really interested, hit me up. I can help walk you through that. It's not super straightforward, but it's not terrible. So if you want to get a local install, follow these links. Otherwise, you can use this link right here for remote access. So just slap that in your browser. I recommend downloading the Horizon client. The limited amount that I've actually used this, Horizon seems to be way better. It has less lag. It's got better latency. You can go full screen. It's got all kinds of stuff. But if you don't even want to do that, if you just want to get access to this stuff through your browser, that works too. You just use your Kerberos login. And it takes a second. Brief aside, if you guys have access to an external monitor, well, that's bad. I recommend getting that set up because it'll let you, that way you can put the screen that I'm sharing up on your second monitor, and then actually work on whatever software we're working on your primary. And that, sorry, one second. It'll be a lot easier if you can see what you're working on and what we're going over at the same time. Okay, this is weird. Is anybody else able to log into this?
I logged into it earlier today.
Yeah. Yeah, I did too. This is weird. Can you guys try to log in real quick and let me know if it actually works?
Yep.
Yeah.
Worked for me.
Worked, okay. Helps if you remember your password.
Yeah, I'm in.
Cool. Okay. So SolidWorks is going to be, should be just on the desktop. Everything else is going to be, you'll access through the start menu. So you can search, or it's going to be under AutoCAD. So that's how you get AutoCAD. It's under the AutoCAD folder. Automation Direct, click PLC programming. That's our ladder logic software. Is under Automation Direct, and that's it. That's installed here. The one other thing I'm hoping to get worked out is there's a touchscreen programming software for the industrial touchscreen on our panel. That isn't free. I've been trying to work out licensing with them for a while. They keep telling me to wait because I think they're going to make it free. But there is a demo version out there, and there's a couple other things that we can probably work out if you want to, if you're interested in learning how to do that. I think that'd be really valuable. So we'll talk about that more when we get to it. But just be aware that's coming as well. So again, if you're not going to install local copies, this is where you're going to go when we're doing live work. which we'll do more of today. So we already talked about ladder logic. So moving on into industrial automation. So a lot of you guys probably joined this class thinking like, okay, it's just AutoCAD, right? It's called CAD. And I think we did a little bit of a disservice naming it CHEM-E-CAD. We probably should have called it Universal Engineering or something like that. Because AutoCAD is really fairly simple. Like it just draws lines and circles. That's all it really does. And so it's important to be competent in AutoCAD, but really you're just drawing stuff. And so it's more valuable to actually start looking at things like piping and instrumentation diagrams, right? P&IDs, and electrical schematics, and kind of focusing on that and then drawing those as we're talking about how you develop that stuff. So industrial automation is really what my background is in. And so that's dealing with control for things like utilities, building management, all the robots and conveyors and vision systems and material handling stuff that goes into manufacturing. All that kind of stuff is controlled by automation platforms. And there's a lot of electrical design that goes into that and a lot of mechanical design. And then also some people engineering. I know there's a term for that, but basically it's kind of related to ergonomics in the sense that like you want it to make product flow easy for people, so they fit in well. And so all of that kind of falls under the umbrella of industrial engineering. So we're going to look at some of that stuff in the context of creating schematics, creating control software, and hopefully introducing some concepts that you kind of touch on in these classes, but it's more in our major, you're more focused on kind of the physical phenomena, and not so much the nitty-gritty of like how you wire sensors and how you actually program ladder logic. So hopefully that makes sense to you guys. If it doesn't now, hopefully it will over time. Actually, that's what I just talked about. So real quick, I just want to go over what a PLC is. So you have a central processing unit, just like you do in your computer, right? And it has associated memory. And then on the physical field side, you have inputs from sensors, and people actually. And then you have outputs to motors and lights and speakers and just about any other electronic or pneumatic device you can think of. You can control that with an output from the PLC. And so basically what you're doing is you're wiring a button on this side. You hit that button, some programming stuff happens in this yellow box, and it outputs something into the field. So for example, you might have a start button that starts this motor. And I know that sounds really basic, but as we get into this, you'll see it can get complicated and it's incredibly powerful. So it's pretty much any industrial manufacturing or large-scale building has some kind of PLC type control system installed. So the control hardware associated with these systems are what we talked about, the PLC. So that's the computer that everything's wired to. And HMI stands for a human machine interface. So that can be any kind of button, touchscreen, keyboard, mouse, whatever. It's how a person interacts with the control system. You're going to have a bunch of motor control components. You'll have a bunch of sensors that are inputs to the control system. And then you'll have outputs in the forms of lights, alarms, motors, heaters, etc. So we have the first three available to us. I'm not going to hook up a heater in my house because I don't want my landlord to kick me out. So just an example of what I'm talking about. If you have your air conditioner in your house, so you may or may not know how this works, but we're just going to go through it real quick. So your home AC is broken up into different modules. You have your control head, which is the thermostat. You have, sorry, we got a lagger here. Hey, Cody. So you have your controller, you have a user interface, you have sensors, you have a heater, a cooler, and a blower unit. And so in this particular system, the human interface and the controller are one module, right? That's your thermostat. That's where you go and punch in your temperature, and whether you want it to cool or heat and what times you want it to run. And then you have really one input. And when you're talking about an input, you're talking about a sensor input to the controller that is monitoring continuously, right? Not human input. And so the one real input we have on most AC systems is a temperature sensor that's installed somewhere in your house. Usually it's actually just on the thermostat. And so that's just looking at the temperature of the room. And once that goes below or above a certain threshold, your AC automatically turns on and it kicks on the cooler or heater and the fan, right? And so that's your outputs. That's your run signal to the blower and then run signal to your heater or cooler. And so this is a really great example of an automated system. It's really simple, but it's something that you can probably all relate to. And so that's why we went over that. So I think now, in the time we have left, let's draw AC system in AutoCAD. So, wow, that's obnoxious. Okay, so everybody get AutoCAD pulled up. If you have it, however you want to do that. So if you have it installed locally or if you're accessing it through the remote system. Bear with me. By the way, if you are going to install a local copy of AutoCAD, I think the oldest version you can get through that link I have is 2018. If you want to put in some legwork and try to find 2016, 2016 doesn't watermark your drawings with a student watermark, which anything after 2017, when you save the drawing, it's electronically stamped with a student watermark, and you can't remove that ever. So it might behoove you to get a 2016 version if you can. Does everybody have AutoCAD pulled up? Let me know if you don't.
Yep.
It's asking for a license.
Okay, are you remote or local?
Local.
Okay. Did you just install that today?
Yeah.
Okay. You should have got an email with the license, but you might want to just go remote for the sake of expediency. Okay, I'm gonna go ahead and move forward. I'm gonna assume everybody has it fired up. Let me know if you don't and you want me to wait. So the first thing you do is go in here and hit in the upper left corner, hit the new button, and it'll pop up this to select a template. Just use the default acad.dwt.
Okay.
So that'll open up a blank drawing like this. So for those of you that have already been through this, apologize for the repeat, but a refresher is always good. And hopefully I'll cover some things better than I did last time. So in AutoCAD, there's multiple viewpoints. And if you look down in the bottom left-hand corner, right now we're in model space. This is where you want to do all of your drawings, okay? So anytime you make a change to a drawing, make sure you're in model space. Now, there's a couple of layouts here. So by default, when you open it up, it'll have like layout 1, layout 2. These are like windows into your model space, right? And you can define these however you want. And what it's going to show is a certain slice of content that you tell it to in the model space. So it's not necessarily going to display everything you've drawn in model space. So I'll just give you a quick demonstration of that. I drew a big circle. That's not shown in my model space. Okay, so what I did is I reframed my model space to show that circle fully. Now I can zoom this in and out, so I can show more than that circle. I can show a small chunk of that circle. So just be aware of that. Whenever you print a drawing to PDF, you're going to do it from this layout space. And so as we get further into this, you'll see it becomes very important how you define this stuff, how you zoom it, in order to get it to export correctly. For now, we're just going to draw stuff. Don't worry about that. But be aware that you need to always be in model space when you're drawing. Okay, so some basic commands. When AutoCAD was first created many, many moons ago, pretty much everything was text-based. So you would like type in the coordinates of where things went, and there was basically no point and click. Over time, it's really evolved to let you use your mouse and your mouse a lot more and click around and do stuff. So you can see like there's like line and polyline and circle and all this stuff up in the top left-hand corner that you can click on. But for the sake of working quickly in AutoCAD, it's good to memorize some basic commands. And this will come with time as you do more and more drawings. But the first one is that to draw a line, all you have to do is hit L and then press enter. So I've now opened the line command. And so now all I have to do is click where I want my line to start, drag it over, click where I want my line to stop. Now, one of the things about AutoCAD is usually, at least with lines, and I think with a lot of other shapes, is that like it keeps creating them as you click through, right? And so you can see like everywhere I click on here, it stops that line and starts another line. And so whenever you want to stop drawing lines, just hit escape. Everybody following? Any questions? Cool. Okay, so now we have a big mess of lines. Hopefully you drew a big mess of lines too. We're going to go over the different selections. So to select in AutoCAD, just hammer escape. Pretty much no matter what you did in AutoCAD, just hammer escape a bunch of times to deselect everything before you move on to your next thing. So if you're ever trying to do something and it like keeps drawing lines and you want it to stop, just hit escape. So to select, if you go from left to right, just click, don't hold it down, and just move your mouse over, right? And if you go from left to right, it's only going to select the things that are completely encapsulated in that box. So if you see here, as I go through here, nothing's lighting up, and then all of a sudden that one line just got highlighted. It's bigger, right? It means I'll grab that one. So whenever you have, once you have your window selected of everything you want to select, click, and now you can see, again, only those lines that were completely encapsulated in my box are selected. So this gets really important when you have complicated drawings and you're like trying to move stuff around or trying to delete only certain things. So if you go ahead and click the delete key, it'll whack everything you just selected. Right? Now, that's all well and good, but that can get really annoying if you want to like grab a bunch of stuff and it's hard to get the full extents, right? So like I'm close, but I'm not all the way there. So if you go, if you start your selection right to left, everything it touches gets grabbed. It's like in the Lion King, right? Like everything where the light hits, that's what I'm gonna select. So you see here, I can actually go from like right here and grab everything in my drawing so far, right? So I know these things are, I know I'm taking a lot of time on this, like one little thing, but one of the pieces of feedback I got from previous quarters is that I really like rushed through things too fast. And these are the fundamentals that will make your life good when you're drawing stuff in AutoCAD, because it is a relatively simple software. But if you don't get these fundamentals down, your life's going to be tough because you're going to know exactly what you want to do, and you're going to feel like you're telling the software to do it, and it's not going to do it, and it's going to be super annoying. So I'm really going to take the time to go through this step by step, slowly, try to be super clear. So if I'm boring you to death, sorry. We want to make sure we get this right the first time. So that's lines. Now, if you want to draw a box, you can go up here in the top left, do the same thing, just click and drag. Now, if you'll notice, when I get in a certain geometry, it creates that slanted green line going across, right? And that just actually means that I'm making a square. And so AutoCAD does a lot of nice things like that for you automatically. So even though you're making a rectangle, you can also make a square if you just follow that green line and click. Okay, so that's a square. So same thing for a circle. And then a polyline is basically just, it's the same thing as drawing a bunch of lines, kind of. But it has a few, basically this is all, instead of being separate lines, it's all one single line. So that can be useful depending on what you're using it for. Generally speaking, I would say just use the line tool and make multiple lines, because there's commands to group and ungroup those lines, which I think should work here, maybe. Yeah. Okay. So I'm going to redo that real quick. So if you make a polyline and it has all these multiple line segments, it's frozen. There we go. Okay. So even though this has a bunch of different segments, AutoCAD is treating this as one entity, right? This is one piece of geometry in AutoCAD. Well, what if I want individual lines in this shape so I can manipulate those lines however I want? Well, there's a command called explode. And so what explode does is it takes any entity like this that has multiple pieces that are joined into one group, and it separates them. So make a shape like that using polyline and then type explode. And you'll see now that these are actually separate entities, right? And you can individually select them and you can drag them away and manipulate them individually. Cool. So now what if I did my little manipulation if I wanted this line to be over here for some reason, right? I don't know why. We're just gonna, let's pretend that that's a good thing to do. Oh God. So now I want to turn that back into a single entity, right? Well, I can select all of those and then type group. We got a raised hand here. What's up, dude?
Yeah, so I'm trying to explode a box that I created, but it says 6 objects cannot be exploded. Wondering if
Let's try it. So I'm gonna make a box.
I think it was because I did individual lines to make the blocks.
Oh yeah, okay. So that's what I was about to go over. So if you have, I just have a line here, right? If I select this and try to explode this, that is its smallest entity that it can be, right? You can't break this into like individual pixels. A line is the most basic entity you can have in AutoCAD. So it's not going to let you explode that into smaller constituent items, right? Go ahead.
More so like I created a box with all the individual lines. I grouped it, and I thought
Oh,
it's
you did?
the reverse of group, but it's not.
It should be. So let's explore that. So the next thing I was going to do is show you how to group it. So if you select all these things and type group, did I already do that? Huh.
So group doesn't let me manipulate the individual lines like a polyline does.
Right. Okay. Why is this not working? Hang on. I think we've confused it. I'm gonna make a new thing. Okay, so this is what a polyline gets you, right? It is one, like you can't select just one line segment. So I'm gonna explode this, and then I'm gonna group it. Okay, so now it's one group. Okay. Group is not working the way I thought it worked. So I may have been mistaken about that. Okay, well, I know another way to do this. So if you type in block, it'll come up with this block definition tool. So a block is a special kind of object you can create, and this is really good for if you're like creating a hardware module or something that has a bunch of individual pieces. You can draw them individually, and then when you create this block, you can name it whatever you want. I'm going to call it polygon. Create it. Now this is one individual item, right? Like it was before when we drew it. But if you double click on it, you can edit that block specifically in the block editor tool. And so this is powerful because what you can do is you create, like, let's say you have a specific module like a power supply, right? And so you create a block for that power supply and you save that as a block. You can recreate that power supply by just copying that block in your drawing. And then let's say you made a mistake when you were drawing it, you can go in, edit that block, and it'll edit every single instance of that block in your drawing. It's kind of like a function block in programming, right? So if you have a function that's being called in different software, you can go edit the original source function, and it'll then be changed for all the software that calls it. So I'm going to save my changes, and now you can see in the main drawing, it's all screwed up and it's not a very good polygon anymore. So to be honest, I thought group worked that way. but apparently not. So I'm learning along with you guys. It's really weird because I really thought, I swear I've taken it before and grouped together a bunch of things and had it stick together in one shape. So you can explode a block in the same way you can explode a group, right? Don't worry about what I'm doing right now. Okay. Onward and upward. So we went over blocks and groups and how to draw different shapes. So now I want to go over some of the more important settings for these drawings, which is down in the bottom right hand corner here. So the first thing on here is displaying grid, right? You always want to keep the grid on. It just helps give kind of a sense of scale to your drawing. I mean, I guess if you really hate it, you can turn it off, but I always use it because there's another snap mode called grid snap. And if you have this on when you draw things, if you look at how my cursor is being moved, it's snapping onto those grid lines and it won't, it'll only move to a point in that grid, to an individual node in that matrix. So this, some drawing or some companies have a drawing standard that requires you to keep grid snap on at all times. There's advantages to that. It's super frustrating to work with sometimes if you're used to drawing things and without it. But it basically makes everything very square in the geometry. And so I almost never use that unless there's a really good reason to, but it is there if you want it. So zooming back out, restricting cursor orthogonality. So this just means if you have this on, you can only go at 90-degree angles. So if you draw a line, you can literally only go north, south, east, west. You can't go on any other angles, right? Super annoying. I usually leave that off. The next one in line is restrict cursor to specific angles. This one I usually keep on. And so I usually set it to, you can set it to whatever you want, and you can actually even customize this. I usually keep it 30-60. So when this is on, it actually doesn't even lock it, but it'll just give you whatever angle set you selected as you move. You'll see that green line when you get onto one of your angles in your set, and it's just showing you that projection, and it's saying like this is 30 degrees or 60 or 90, right? You can see why this would be super useful for certain drawings. So like I said, I usually keep that one on. The next one is isometric. So this is actually creating like a virtual 3D drawing. And so if you kind of like follow the lines, you can create things in basically draw in perspective. So if you wanted to like draw a box in perspective, this lets you do that. So this actually gets used a fair amount for like installation drawings. We'll go over this a little bit more later, but it is kind of cool that it's there. So as you can see, I just real quick drew a box that's in perspective in this ISO plane. So again, we'll go over that more in detail later, but it's just a handy way to let you draw. You're still sketching in 2D, but it's isometric, so it looks like you're in 3D perspective. The next in line is snapping reference lines. You can keep this or not. It's for object snapping, which we'll go into right now. It can be useful. So object snapping is probably one of the most important things to get set correctly and to be aware of when you're doing drawings in AutoCAD, because it's how you stick things together. And so if you click on this little drop down in the bottom right, it pops up all these different snap options. Now, by default, I think most of these should be selected. I usually keep the first 8 on at all times, and then tangent and perpendicular are also really useful. And so what these settings do is when you're drawing lines, so I'm just going to draw a line. I'm just going to make a triangle. You can see when I bring my mouse down close to the end of this line, it gets this green box around the end of the line. And what that means is it's doing a snap. And that box means it's doing an endpoint snap. So that just means that if I click while that green box is showing, it's going to snap the ends of those lines together. Okay. It's useful because you might, if you don't have that on and you bring your line and you think, okay, those are touching, right? Those are really close. But if you zoom in, they're actually not. And one of the really important things in AutoCAD to have is actual true intersections between all your lines and all your models, because, and we'll go into this more with further commands, but because if you don't have that closure, then a lot of commands aren't going to work correctly in AutoCAD later on down the road. So definitely keep snap on and be aware of what it does. So there's a, see, the next one is, so that was an endpoint snap. The next one is a midpoint snap. So if you have midpoint on and you mouse over near the center of any line, it'll show you that green triangle, and that means that just means it's snapping to that midpoint. So you hit that, and you can see it lets you draw the Triforce. Man, this is even weirder than being in a classroom because there's like 0 feedback. So I don't even know if you guys are at your computers.
Whoa, that's so cool.
Hey,
This
there
is
they
a
are.
robot talking.
Oh,
That's right. I'm at my computer.
you guys programmed a robot already? I'm so proud of you. I'm not even mad.
I drew a triangle.
I have
Dope.
a mess on my screen.
That's good. That means you're learning. The first trick to making omelets is breaking eggs. Okay, so next snap thing is the center point, and I'm not sure if that's going to work on here. Yeah, that's probably not going to work on here. Okay, so to show a center point snap, let's draw a circle. We have a beautiful circle. You press line. Now mouse over that circle, and then go to the center, and it makes a little green circle in the center, and that means we're doing a center point snap. So I think that center is only for actually only for circles. There's also geometric center, which works for like rectangles and stuff. So the way you engage that snap is any geometrically balanced. I know there's a symmetric shape in this software. When you mouse over it, you'll see that little white dot in the center. And so that just means that's the geometric center. If you don't know what that means, ask Dr. White. He can explain in mathematical terms. But that also means that our Triforce wasn't geometrically centered, which is unfortunate, but I think I also knew that was going to happen. So that's super sad. Let's fix that. So go ahead and delete your Triforce and let's start it over. So draw the bottom line on the plane. Draw this next one. Where are you? At a 120 degree or 60 degree angle, depending on how you want to look at that. and then draw another line starting from that other bottom side, also on that 60 degrees. Cool. So now that kind of looks like a teepee, right? And we want to get rid of these little extra things. So what we're going to do is select those lines. Does everybody have this? I'm going to assume that's a yes. Okay. So if you select those two lines and then type trim and hit enter, and then mouse over these lines and then click, it'll delete those little doohickeys that are sticking past. So this is, you can see this is kind of useful because I just realized something. No, that should be, yeah, that should be symmetric. So that trim command just lets you delete things that are sticking off. So if I wanted to get rid of the thing sticking out here, I could do the same thing. Now, the cool thing about trim is what happens is you select something that's your defining geometry. In this case, that's the circle, right? So that's my boundary. Now with trim, I can delete this inside line or this outside line, right? It's whatever's on one side or the other of that defining geometry you just selected. And so if I wanted to get a weird like line sticking off of a circle for whatever reason that's pointing towards the origin, but it doesn't actually go through it, I can just draw this tangent line from the center and then, or not tangent line, whatever that line is, draw that and then delete it, trim the inside, right? So now I have this weird little unicorn sticking off of my circle that like I have no good reference geometry for. And so same thing here. So if I select this triangle, go trim, I can delete that line in the center. So that's a super useful command because sometimes it's hard to get things drawn perfectly from the get-go, or you might be wanting to make something that looks super weird like this, and manually drawing these intersection lines might be a total hassle. Useful trick to have in the book. Okay, so now I wonder if that object snap is going to work. Okay, so the center point snap is going to work. So I think this is what group is for actually. So select that triangle and group it. And now it still doesn't work. Okay.
Tried it with block, doesn't work either.
Block doesn't work either. It should. I've done this before. Well, the super nice thing about AutoCAD is if you can't get it to work the fancy way, there's always a way to do it manually. So what you can do is draw, get a center point arc from here and draw it through the vertex of the opposing part of the triangle, and then do that again over here. And then again over here. And now we have our geometric center of this thing right here. And actually, now that I'm thinking about this, I don't know, we need to ask a math guy. It might be that the software just doesn't calculate a geometric center. But now I have that center point that I can draw lines from, okay? And so if I want to get this weird line, I can get that. And then if I don't want these reference lines here anymore, I can delete them. Now, this is a good opportunity to start talking about layer control. And so basically what AutoCAD does is it lets you define layers in your drawing. And you can basically think of this as like if you had like that clear, you guys probably never saw this, but anybody that saw that like old school overhead projector that had the clear plastic sheets that you could like draw on with marker and then it would project, that's kind of what this is. So if you imagine just like a clear sheet and you're drawing on it with marker, well, you can just keep laying these sheets on top of each other layer by layer, right? And in the end, you'll have this big stack of sheets with all these things drawing on them. But if you're looking at it straight down, it looks like it's just one big or one drawing that's on the sheet. So by default, there's only one layer, the 0 layer, in this drawing. And so if you go over here, where is it? I just hit layer properties. Come on. Okay, so if you hit that layer properties button in the toolbar, it'll pop up this guy. And right here, you can see this tiny little button for making a new layer. You can also hit Alt-N or not. Apparently that doesn't work. Okay, so new layer. I'm going to call this reference layer. And I'm going to scroll over. There we go. Sorry, it's being super laggy. So I named it reference layer. And then I don't know how to make this bigger, but if you look over here, there's a color column. Double click that and it'll pop up this select color window. So I'm going to make it green just because that's my favorite color. Okay, so that's defined now. That's another layer we have. So now we can select these entities and go to the layer dropdown and hit reference layer. And it made them green. Woo! So it does a lot more than just letting you turn things different colors. You can set all kinds of layer properties. So you could set a line style. Get rid of that. By layer. And then you can set like a weight. So these actually aren't going to show up in the drawing, but how do I make this display? So that is one of the super annoying things about AutoCAD is like there's 2 billion settings. And one of the things that I haven't figured out very well is how to get your layer settings to display really well in the model space. But your layer line weights, you need to be really careful with this because they all show the same weight on this drawing here, but when you go to print them to PDF, right now this is 2 millimeter, that's just going to show up as like a super thick bar and it's going to like make your drawing unreadable. And so usually leave this as default unless you want to make it super thick for some reason, but be aware of that. Okay, so now I have this reference layer. And let's say I'm done using that as reference geometry. I can turn that layer off and those lines just disappear, right? So the whole point of what I'm showing you is like, yeah, that was some extra work to create another layer and then go in and hide those lines. But if you're doing a really complicated drawing that's kind of relying on some underlying geometry that isn't part of your final product, but you need it to draw everything correctly in reference, you can create a reference layer. And then at the end, when you're done with your drawings, you just hide that and all of a sudden it disappears and it doesn't show up on any PDF exports. But if you want to bring it back to make some changes, all you do is go in and turn that layer on. Turn that layer on, there you go. And it's back. So layer control gets super important. If you're doing like an electrical schematic, you could do a separate layer for like every type of power you had in your panel. So like if you have 120 volts, if you have 24 volts, you can make those on separate layers. And so it helps because you can set, like I said, you can set line properties for color and make them dashed and stuff. And you can also just hide everything that's not 24 volts. So if you're trying to like trace a specific circuit or something, it makes it helpful because you can turn layers on and off through that layer control. So something you'll find in a lot of industrial drawings that in places that have really rigorous standards is they'll be super specific about what you put on different layers and how to control that and how to manage all that. So I think that's the second time I've referred to the fact that, like, if you go to a place that has a lot of drawings, they're hopefully going to have a drawing standard that's going to detail a lot of things about AutoCAD and a lot of these settings. So this is just kind of giving you a leg up on knowing what those things are. But even if you spend a ton of time in AutoCAD and you're really good at it, you're going to get used to doing certain things your own way, right? And then you're going to go and you're going to do work for somebody and they're going to want you to do it a completely different way. And it's going to make you super slow and it's going to be super obnoxious. And that's just, you know, kind of part of the learning curve. You got to come up to speed with their standard and get used to it. Because if you don't, they'll get really mad at you because they probably have some kind of drawing management system and it's going to get all screwed up if you don't do it correctly. And so a lot of big companies have a specific CAD guy who just like checks and brings drawings into compliance with their standards. Okay, enough of that rant. So I think we've covered enough to where now, in the time remaining, we can get rid of all this Frankenstein geometry and do what I said we were going to do from the beginning and draw a schematic for an HVAC. So where do you guys think we should start?
Thermostat.
Thermostat. Perfect. So one of the things you're going to find in these, especially in electrical schematics, is that we're not drawing things to scale. And a lot of hardware modules will look somewhat like they do in real life, but a lot of times you can just draw a box and that's fine. So this is going to be our thermostat, and we can just draw a box and then you can put a little bit of text in there. So if you see, there's a little text option here in the bar. You know what? I'm going to zoom in. So you can change your text properties. If you double click it, you can go in here and change the size. No. This is one of the other things that I'm probably doing wrong. But text is always a pain to manage. So you can either do that or you can just shrink your box down. Either one is fine because all these drawings scale. But now you have a box. Hopefully you have it labeled. Yep. Sweet, cool. I'm gonna assume that's a yep.
My text ended up perpendicular, like sideways.
That's super dope. You should probably figure out why. You might have tagged it like to the corners or something. I don't know. Let me see if I can recreate that.
I'm not sure.
Nope. I don't know. I've never done that before.
I'll try doing it again.
Sweet. Congratulations. You've passed me up. You know more than I do about
I'm a natural
AutoCAD.
trailblazer.
Yeah. Yeah, I don't know. There's
Okay, now I can't delete it. Okay.
There you go. I
I
made
have a
mine
question.
rotated. What's up?
I happen to have deleted that entire, so if you look at the top of your AutoCAD,
Okay.
annotate all that stuff.
Yeah.
I deleted that. Is it possible? Is there a way to restore that? I can't figure it out.
Maybe close AutoCAD and reopen it. I don't know how you deleted it, so I don't know how to get it back. Oh, actually,
Yeah, same.
yeah. Yeah, I don't know, man. That's a new one. You will find that you're going to get a lot of strange errors in AutoCAD. My advice would be start by restarting AutoCAD, like save your file and then reboot or restart AutoCAD. I mean, I know it's just like any other program where you can kind of like customize your tabs and your view panels. So you may have just wiped all that out. I'm not sure. Anyway, okay. So we got our brains. So now let's draw an input. So I'm actually going to turn that snap off because I just want it to be right here. I'm just going to draw a line and then another line. And then I'm going to draw, I'm going to turn snap back on. I'm going to draw a little circle here. And then I'm going to draw a little rectangle here. So I'm going to snap the rectangle on. You guys will see where I'm going with this in a minute. Okay. So I want it to look something like this. Now I'm drawing this freehand. I'm not drawing it to like specific dimensions. So it's okay if it doesn't look exactly like this, like your dimensions are a little bit different. But in general, you want a circle with a rectangle coming out of it like this. Everybody good? So select that rectangle and then type mirror. And we're going to mirror this object. Sorry, I can't talk and type at the same time. So what mirror does is you're going to select an entity and then you're just going to tell it the line that it's going to mirror on, and it'll copy that. It'll make a mirrored copy of that entity across the line you define. So I selected this, I typed mirror. Now I'm going to grab this corner and I'm going to go down to this corner. And then when you click for the second time, it's going to see in the bottom left there, it says erase source objects, and we're going to say no. So we're going to keep those. So now I'm going to go in and I'm going to use trim and get rid of that and that and not that. And I'm going to deselect, and then I'm going to select the circle, and I'm going to trim, get rid of that and that and that. And then I'm going to select all of them, hit trim again, get rid of that. And now we have a thermometer. So if you want to make this super fancy, you can go in, again, turn object snap off, and then just draw in some lines for the gradation marks. Now you see I have sawtooth lines, which looks like garbage. That's fine, because I can just go in and select all these diagonal lines. I swear I can select them. I swear I know what I'm doing. Oh yeah, forgot. So if you hold shift, it actually like lets you deselect stuff but not select stuff. That's a weird ism in AutoCAD. So if you're multi-selecting, you can just go through and like click on stuff, right? And then if you want to deselect, you hold shift and click on the line again. It's kind of a weird little ism, and it's useful to know. So now I have little gradiated lines. So we can label this if we want. Call it temperature probe. And then again, we probably want to resize that text so it's more legible. Maybe not that big. Cool. So now I got a thermostat with a temperature input. What else should I draw on here?
And
What's that?
a fan.
Fan. Okay. So I'm going to draw, again, I'm just going to draw a line, go out, and go, I'm going to go down for this one. Oh.
Hey, John, I was wondering if there's like standardized symbols for this stuff.
Yeah, there is. So that's one of the things I'm working on is getting a P&ID library when we go over that. So again, that's one of those things that it's going to be, there's ISO standard symbols, and then there'll be company standard symbols. So yes, I'm working on getting all those. I don't currently have them available. Plus, this is a good exercise to just draw things by hand. But yeah, 100%. If you're doing like this is like a schematic or a P&ID or something, you definitely want to use a standard library for these things instead of recreating them by hand, because then anybody who's looking at your drawings can go and look at the reference page that actually has a list of what those symbols are. So they don't have to guess like, oh, that kind of looks like a fan with a heater on it, and maybe they put a VFD on there and that looks like a mouse and I don't know what that means, right?
Yeah, okay, thank you.
Great question. Okay, so let's go to the end of that and go down a little bit and draw a circle. And then let's draw an arc. Ugh. So this is going to be our representation of a fan, is just use an arc. Oh man, that's not working at all.
Copy and rotate tool, maybe?
Yeah, you could definitely do that too. Good call. So what you can do is select this and go copy. And then you select the point you want to copy and where you want it to go. Now I just copied that on top of itself, but that's okay. So now I'll select it and type rotate. And it'll freeze. And then I'll specify the base point and then type 90. And that rotated that object 90. So I'm going to do that again 2 more times. So copy, base point, copy to there, and then I'm just going to copy to there again. So there's now going to be 3 entities that are all layered on top of each other right here. So go rotate, 180. Oh, whoops. Forgot to specify the base point. Rotate. Select your base point. So I'm going to go 90 again. And then 1 more time. You guys are probably already done, huh?
And did you stick the circle on the end of the line? Did you snap it or did you just freehand it?
So I kind of did it freehand.
Okay.
So what I did is I went circle and I went snap on the end, and then I just dragged it down, like straight down to wherever I wanted.
Oh, so you built it on the end of the line and then just moved the whole circle down?
No. So I went down and selected that, and then when you click at the start of your circle, go up and drag back to the top of the line.
Oh,
Right. And so now, so you basically, when you went down from the line, you're setting your radius and then you're just dragging back up to the line and locking it in place.
oh, gotcha.
So you could also just make the center on the line and then trim out, like you can make your line extra long and
Yeah.
then trim out the line. There's a million ways to slice the cat in AutoCAD. So I encourage you to experiment and find faster ways than me because I'm probably pretty slow. Okay, so the other thing I can do is rather than recreating and resizing my text, I can just grab a box and literally hit Control-C, Control-V, and just copy that text box. So that way I can just go in and write in whatever I want. Instead of recreating the text box from scratch every time. So in general, I strongly encourage you to use the copy command rather than just copy pasting things. But copy paste is an option in AutoCAD and it works fine for text boxes. For something like this, that's a little more complicated, you would want to go copy and pick your defined reference point and then move it over to wherever you want it to go and snap it on in place. And so what copy is doing is it's basically saying, I'm going to copy this whole thing, and wherever I click on that thing is my base reference point, right? And so I could pick like this point as my base reference point. And so when I copy, that's what I'm going to snap onto some other geometry, right? And it lets you snap whatever object snap options you have on. That's what your snapping options will be that are available. So, and Control-Z works great in AutoCAD, so it's super useful. So if you want to just get rid of that stuff. Okay, so we got a blower motor. What else do we need?
Heater.
Yep, heater and cooler. So this is one of those instances where it might be good to go ahead and just draw this a little bit more, like not just as an electrical schematic, but more representative of how the mechanical system is configured as well. So what we'll do is we'll just draw two rectangles here. And we'll label them. So grab a couple text labels. Actually, put those below, not above. So we'll call this one heater. And call this one cooler. And so for the heater, we'll go line, jaggy line, line, arrow, arrow for heating up. And then for the cooler, we'll go line, jaggy line, pointed down. Boom, boom. So now you have a heater and cooler. And to top it all off, we're just going to show another big rectangle that I didn't put in the right spot. So we'll move that around like that. And we'll grab a big label here. We'll call that ducting. And so what we're doing is we're showing the control scheme, but we're also showing like the physical layout of like, you have this big AC duct with a blower in it, and then you have a heater and a cooler. And this is not exactly how AC systems work, especially not in your house, but it's close enough. You get the idea. So now you're showing, not only are you showing your control connections, but you're also showing a little bit of mechanical layout. which is helpful. So now we need to show, okay, I need a control line from here. I need another control line from here. Cool. Okay, so those are my wires. So I need one more thing. Anybody? Anybody?
An interface?
And yes, a human machine interface. So for your thermostat, that's actually that's just on the module itself, right? So the temperature probe, the controller part, and the actual human interface are all in one module, and that's your thermostat on the wall, right? But that's okay. We'll just show that as a separate box, and we'll call it touchscreen. There's that. Okay. I'll draw a line. Okay, and now I'm going to put a note. C drop out menu. Okay, and now over here, we can go and create drop out menu. So this is something that's probably not the right name for it, but this is something you'll see come with a lot of hardware modules that are configurable, where they'll have a menu tree of like, okay, here's main menu, and below that you have 1 app, 2 mode, 3 timer. Okay, and so then we'll have a little arrow. Oh crap, I have snap on, turn snap off. So then we'll have a little arrow to another set of things. All right, get another line. For mode, so our modes could be continuous. Oh, sorry. Oh, that's not what I was going to do. So we can do heat, cool, fan, off. And then for our last one, timer, go down, grab that again, go timer, and let's say continuous AM, PM, user defined. Okay, and then off user defined, we're gonna have, grab that, start time, stop time. So this is maybe a little overkill for what we're doing, but this is an example of something that you might want to include on your drawing for this system, right? So all I'm showing is like on that little touch screen on the thermostat, right? You might have a few options, and each one of those options might have a sub menu that it navigates you to. And so that's literally all you're showing here is how that controller, when the person is interfacing with it, what that kind of options tree looks like. And then you could have additional details of like what the acceptable temperature setting ranges are, right? And what these operation modes do, and like maybe some details on how to use or define the timer, that kind of thing, right? So it's just a little, I don't know, fun little add-on I decided to do here. But you can see like this, you could clean this up and make it look better, but it looks kind of professional already just by doing it in AutoCAD. Whereas like if you were to do this in Microsoft Word, it might not be very easy to get this kind of layout, right? And I know there's stuff out there like Visio and stuff that might be easier to get this kind of layout, but I'm just showing you like you can pretty quickly create this kind of stuff in AutoCAD. And so my hope is that, you know, you guys get super slick in this and start using it for classes like 158, where you have to make diagrams and schematics as part of your assignments. And then maybe even like, we'll see for senior design. I'm not sure, but I have a feeling that I'm going to wind up drawing a lot of my, a lot of our stuff in AutoCAD rather than Aspen. So, okay, cool. So now I have my system drawn out here. Let's do some coloring. So change this stuff to by block. So select the ducting, and I want to make that silver or gray. And then let's go in here and select all the control wiring. And let's make that green. And then because this has to do with temperature, let's make the thermometer be yellow. Oop, but I grabbed the text, which looks like crap. So change the text back to white. Okay, and then let's make the cooler. Let's make the cooler blue. Let's make the heater red. And then I think white's good for the blower. Cool. So now we have a little bit more color detail on there. It's a little bit more obvious what things are. So I have zero artistic talent, right? This doesn't look the greatest, but I'm sure a few of you are more creative than I am. And with a little bit of practice, you can get this kind of thing and make it look pretty slick. So that's a basic automated system and a basic schematic with a little bit of mechanical detail. And we knocked that out in like, what, 45 minutes, right? Along with a few teaching moments. So I'm guessing with a little bit of practice, you guys could probably draw this out in like 15 minutes or so. So we got like 15 minutes left. I don't think I'm going to dive into anything else more complicated, but let's take this moment to discuss and answer any questions you guys might have about how this class is going to go. Don't everybody speak up at once. So does this just mean I was like crystal clear and you guys know exactly what we're doing? And
Yeah, you
nobody
were
has any-
nails. No,
What's
but
that?
can you see the chat as you teach?
Yeah.
Oh, okay, good. I was just wondering.
Yeah, I can now. I didn't have that up at first. So that's why I didn't see your question.
You're good.
Have y'all youngsters used twitch.tv?
Of course.
Yeah.
No.
Yeah.
So I haven't, but I'm thinking Twitch might be a little bit more user-friendly platform to do this in. So I don't know. Does anybody have any reservations about that, or is that cool with you guys?
Whatever you say, boss.
Try.
Okay. Well, I'm gonna do some experimentation through the rest of the week. My camera hardware is supposed to come in on Wednesday, I think. That's my wife. Hi. Stella, come here.
Just found out that there's actually push to talk.
Oh, nice.
Yeah, it's spacebar.
What's up, guys?
Weird
This is
place.
my other dog.
Damn.
You're good.
Nice
Come on
dog.
in. It's fine.
I thought you were done.
No. We go till 8.
Apologies.
It's all good. I got food.
Me too.
Random quick question. Is there an
Yeah.
easy way to slide around the workspace, like pan? Because it's annoying, like zooming in and out to look at different parts of the model.
I don't think so.
There is actually. Just type in pan.
Oh,
Yeah,
there you go.
you can just do P enter.
There you go.
Or if you just click in your roller, you can just move it manually. It'll make a fist and grab whatever section you want to go to.
Whoa.
Yeah.
Today I learned.
It doesn't do that when I try it.
Do you have a mouse scroll wheel?
Yeah,
That works for me. The little scrolly wheelie thing.
It's working for me.
never mind. I was doing it wrong.
I have a super fancy mouse though.
Wow.
It's from the aliens.
Okay.
Cool. So as far as timing, what we cover and when, do you guys have any input on, do you want to keep doing AutoCAD for a couple of weeks? Do you want to go straight into doing some controller programming and jump around?
I think starting in AutoCAD would be sick.
Yeah, stay in AutoCAD for a little bit.
Yeah.
Okay.
Yeah.
Maybe
Yeah,
just one
I'm
more
just
week.
along for the
Maybe for
ride.
like a week or so, at least.
Okay, that's fine. So I think what I'm going to do next week is, again, hopefully I'll have a camera that I can pan down so where I can draw stuff, and I'll rehash that lecture I did the first quarter on, and I think second quarter on electrical schematics and basic circuitry, because then we can start drawing that stuff in AutoCAD. And then from there, it's kind of a natural progression into PLC configuration. So next week, probably what we'll do is we'll do two 1-hour sessions. The first one is just going to be kind of going over circuits, and then the second one will be drawing in AutoCAD. If you guys have any specific stuff you want to work on, like specific areas you're interested in as far as what we're going to be drawing, let me know, because I want to try to cater this to your desires and stuff. And I'm more than happy to like stick to PLC architecture because that's what I know really well. But I'm happy to branch out as much as you guys want. And I like your dog, Samaj. That's very nice. Also, Sam, did you purposely flip upside down, or did your camera just do that?
No, I did that.
I'm glad to know that you're not spiraling out of control.
I flew to Australia while we were doing this.
I thought it was just toilet spinning backwards. I didn't know they actually hung upside down.
Literally on the
Everything's
other side of the
upside down.
planet.
Yeet. Where'd you get that travel pass?
The black market.
How's everybody's quarantine going?
Boring.
Alright.
That's horrible.
It's the worst.
Must
Mine's-
be him.
Beaver.
Hey.
Hey, bees. Andrew, I like your background. It's very UC Davis, CHEM-E. Dude, this is gonna, I don't know. It's such a bummer that like our last quarter, we're just gonna like finish up online and then probably not go out back on campus again. It's gonna be anticlimactic. Who is that?
No one wants to speak.
We're gonna do graduations through Zoom? Are you serious, Evan? Or are you making a joke?
There's Zoom.
I mean, we should definitely have a Zoom party.
I agree.
This is super cool.
Yeah,
Yeah, it's pretty.
it works
neat.
pretty well. So it makes me happy.
Direction. Jesus.
And it's got
Better
the
in the
cool
sky.
background.
Yeah, I'm gonna have to play with my background. My empire of dirt is not that impressive.
Could you make that an extra credit assignment? Whoever has the best next time. Graduate.
Yeah, we'll definitely do. We'll take a vote. So pick your background, and we'll do a vote at the end of the quarter on who has the best background. It's going to be a key aspect of this course. As a matter of fact, it may determine whether you pass or not.
Morale is important.
Yeah. Oh, I know what my background's going to be. By the way, let me know if you have any reservations or issues with the required coursework. You know, we kind of want to see a balance between like having assignments just to encourage participation and like get the creative juices flowing versus like I don't want to just add a bunch of crap that you don't want to do. But I think also like if we don't assign like things to draw, it's easy to kind of not be like, hey, yeah, I get it. I'm not gonna actually put in the work to actually draw stuff on my own. And so, it would be amazing if everybody just went out and spent hours and hours drawing shit on their own, without me telling them what to do. But that's really the only purpose of those assignments, is just to get you guys engaged in working on this, which is, I guess, how school is supposed to work in general. But anyway, let me know if you have any feedback on that. Yeah.
I was gonna say, you kind of blew through the isometric 3D modeling thing, but I can see how it's very useful. Can you go over that
Oh,
in detail next week?
yeah.
Perchance?
Yeah, and we can look at that a little bit more now if you want.
Sure.
So it's isometric. So it's that button there that makes everything look all space agey. And so this is one of those instances where it's actually super useful to have snap to grid on.
Yeah.
And so let's see here. Yeah. Okay. So now, actually, it's not snapping. There we go. Okay. So isometric is basically it's 2D made to look 3D, if that makes sense. So it's drawing in perspective. I think it's one of the Streets of Rage, maybe. The old Sega game is actually isometric, so it's like you can, it's a side scroller, but you can move up and down too. Super badass. You guys probably never played that. I'm just now realizing. Anyway, so
I think Fallout 1 was isometric.
was it? I never played it.
I think so. It's pretty cool.
Nice. Yeah, I gotta go back and check that out. I love 3 and Vegas. Okay, so in isometric, you can see there's a drop down. There's left, right, and top, and so we're in the left plane, right? So if we're trying to draw a box, just go line, and because you're snapped to the grid, this should make it pretty easy. Okay, so that's there, and then I go to top, and it changes the grid, right? And so then again, just line, draw the top side, and then if you change it again, and there's one of the F keys does this, but it's not popping up which one cycles through. So anyway, and again, I can just draw that side. And so bam, now I have a box, right? So this is useful. Where I've seen this done is like for instrumentation installation drawings, is the one place I've really actually encountered this myself. And basically what they're doing is like they use it to show perspective for the installation lines. So like it would go here, here, and around here. Actually, let me redo this. One sec. So like, say this is an actual physical box in the field. Like you could show that like, okay, I want my wire to come in to like right here, and then go down, and then go under the box, and then go, and then change your perspective plane, and then go from there around the box, and then up past the box, and then change my perspective plane again, and go over the box. So you now have 100. I'm changing your backgrounds. So you now basically know as much as I do about isometric. It's just like literally all it's doing is changing the grid plane behind what you're drawing, so that you can snap to it as a reference. It just makes it easier to draw things in perspective. I'm sure there's all kinds of crazy complicated stuff you can do with this, but that's pretty much, I mean, that's pretty much the extent of it. That's all I've ever done. So yeah. Make sense? Sweet. Okay. I think that's time.
Thanks, John.
Don't forget to email me if you want
Yeah.
access. Yeah, no problem. Don't forget to email if you want access to the Google Drive. Any comments, questions, concerns, abuse is always appreciated. And I will send out, I don't think I'm going to assign anything for this week, but I'll send out updates about our format and where you can find these videos online and all that good jazz. So thanks for coming, guys. See you next week.
Thank you. Wait, it's next
See
you
week.
later.
Bye, everyone.
Sorry,
Bye.
it's next week gonna start that 1 hour session on Monday and Wednesday.
Yes. We're shooting for Monday, Wednesday right now. I will send you an update about exactly when we are going to meet.
Okay, sounds good.
Sick.
And then if for those of us who can attend one of those 1 hour sessions, we just need to watch the recordings.
Yeah, you can do that. If you do have conflicts that can't be resolved, I can try to do a third session and kind of like catch the people that aren't able to make it to the regular ones. And so if we do that, if we do need to do that, hopefully we don't. What I'll do is just ask that you try to watch the videos before we meet, and then we can kind of do like a live catch up and work that out. Does that
Okay.
work for everybody?
Sounds good. Sounds good.
Okay, cool. Thanks everybody for your time. See you next
Peace.
week.
All right.